here to pitch on behalf of my team, Gabo, James, Sohail, and Sanvi, for our solution to the XPRIZE Rainforest Challenge. So our goal is to empower the plant through monitoring biodiversity. So who actually are we? Well, you heard our intros, but for the past month or so, we've been going super deep into the rainforest and this challenge. So we're super passionate about saving the rainforest through biodiversity and its struggles. So for the past month, we've been looking through cause analyses, competitors, important species, and different components of the rainforest and the Amazon specifically about how we can help save the Amazon from some of its struggles right now. So the key component behind all of our research has always been biodiversity. That's the main focus of our work. Biodiversity, for some context if you don't know already, is a variety of life across the world or in a habitat or in an ecosystem. So it could be a frog, a log, a tree, a flower, or a certain species of a tree or flower. Biodiversity is a variety of life across all of our systems naturally. So rainforests actually contain 50% of the world's entire biodiversity from what we know. But they only actually have 2% of global landmass. So we have all this biodiversity in these super small relative regions of rainforests across the world. But here's the thing, biodiversity isn't just important for the rainforest itself and for food chains and the rainforest survival. Biodiversity is so crucial for humans and how we survive. Not only does the rainforest and its biodiversity provide us with products like timber, herbal medicines, and fiber, but also the rainforest is a huge carbon sink. Every year, the Amazon rainforest absorbs 2 billion tons of carbon dioxide. So it's actually sequestering carbon and helping us fight climate change. But there's an issue. It isn't just this pretty picture of thriving biodiversity and rainforests helping humanity and everything being just good and well. Unfortunately, because of humans, as it always is, we're hurting the rainforests. Right now, there's thousands of species of organisms in the rainforest that are currently going critically endangered or almost extinct. For example, the jaguar, the South American tapir, or the Amazon River dolphin. And unfortunately, all these species that are so important for humanity's survival are native to the rainforest. So once they go extinct in the rainforest, they go extinct everywhere. And the key cause of this entire issue is mainly deforestation. Deforestation refers to clearing a forest by any means possible. So forest fires, logging, clearing forestry for farms, all of that counts as deforestation. It's the main cause of habitat loss for this obvious reason of killing trees, but being the main cause of habitat loss is actually a key driver as well of biodiversity loss. So here's the situation of deforestation in the Amazon, the biggest rainforest across the entire world. What's happening here is that the main hub for deforestation is the Brazilian Amazon. What's happening is that too much land is unregulated and it's so hard to fight against deforestation because it's hard to monitor. In the Brazilian Amazon, land is being cleared vastly for the purpose of cattle ranching. In fact, 25 football fields worth of forestry every hour is cleared. It's literally horrible. And there's three main causes for this. So cattle farmers coming into the rainforest to clear deforestation are motivated by three main causes, which are social, economic, and political. So for social, education in Brazil is very different from how we view it from Western perspective. Only 18% of all Brazilian citizens have attained post-secondary education. So for us, a job in the future could be in finance, in law, in academia. But for Brazilian people, they don't have the same access to our jobs and our professions. And so for them, their entire goal right now is to make money for their family and to provide for their family. But oftentimes, the way that they have to do this isn't through a conventional position that we'd have in like Toronto or Boston. Instead, they have to actually usually end up doing farming. And this is motivated as well by economic reasons. Right now, Brazil is in one of its worst recessions of all time in its country, and they need boosts for the economy. What that means is that they need ways for citizens to make money affordably with very easy methods so that they can provide for their families and provide for the society as a whole. And thirdly, political reasons are a huge cause as well of deforestation and cattle ranching. Since 1980, there's been government agencies that have tried to save the Amazon and prevent deforestation. But unfortunately, different authority figures and different people in power have fought against these environmental agencies, defunded protection measures against the Amazon, and also deregulated areas of the Amazon rainforest and allowed more deforestation to come in. So these high political tensions, economic recessions, and social causes all come together as a huge reason for why we have so much cattle farming in the Amazon, which is horrible for biodiversity. And here's the worst part. So when cattle ranchers come to the Amazon rainforest to make money for their families, they grow cows and they grow crops. Cows are like the biggest and most popular source of money for these cattle ranchers. But unfortunately, on average, for their entire lifetime, these cows are only worth 800 US dollars. So we're cutting down all this rainforest area and it's being cleared so vastly because we want to make money. But their method of making money is farming with these very inefficient sources, cows. So instead, let's look at biodiversity and what money biodiversity could provide for us, because biodiversity helps us with so many industries. So instead, why don't we look at what biodiversity could do for us and from a money perspective, as opposed to using cows, which are so inefficient and barely give us any money. 800 USD is only like a 50th of the average American's income. But for some reason, it's being so prioritized and so idolized by Brazilian farmers. So our way to combat this is by surveying biodiversity. By surveying biodiversity, we can find new insights and identify new ways that plants can be repurposed or used for our industries. This ties into the XPRIZE challenge, which is what our group is focusing on. So looking at biodiversity, cataloging species in the Amazon rainforest to find potential new insights for our products and for humanity. So for the semifinal round, just for some context, you're only responsible for surveying one story of biodiversity, and you only have to look at one phyla. So a phyla is like a division of a classification hierarchy. If you remember like your biology class in like grade 8, that's what it is. You have to catalog 300 species with 50% accuracy, with insights not required. But as you move into the final round of the XPRIZE, which is obviously our goal, there's 3 stories of required rainforest to survey with 2 phyla, 500 species, higher accuracy, and you need insights. So our goal is to figure out a way to find the most insights and catalog the most species as accurately as possible throughout the rainforest. And to do this, our first phyla of choice to focus on is Magnolia phyta. Magnolia phyta basically refers to any flowering plant in the rainforest. So it could be any of these 4 plant photos you see here, or way more. In fact, there's over 220,000 known species of Magnolia phyta throughout the entire world, and so many of them come from exclusively the Amazon rainforest. So our approach for finding Magnolia phyta as a method of surveying biodiversity is that there's so much of Magnolia phyta and so little space that there's so many species to identify, and so many as well haven't actually been identified themselves. So the potential for insights and the potential for finding tons of biodiversity is very clear. So our solution to actually measuring biodiversity and measuring Magnolia phyta organisms is 2-faceted, so software and hardware. The software side is largely image classification by leveraging CNNs, which is a machine learning technique to essentially classify images. So basically, we'd use a data set of crowdsourced data with images of plants and their species names and train a CNN model to be able to really accurately classify photos of images of plants in the Magnolia phyta phylum with high accuracy, and then tell us about them. It can also identify new organisms and not classify them, but instead send the sum to our remote database and give us these photos for more research. Now for the hardware to actually deploy our model in the rainforest. So our focus right now is leveraging swarm robots to actually implement our model and take photos in the rainforest. Swarm robots are small individual biomimetic robots that function as a group. So they look like bees and they're very small, but they have vast capabilities because as opposed to just one robot, they're multiple robots that function as a collective group. So they can scan much more area and be much more accurate and much more deep into the rainforest as opposed to one chunky robot. Now this is a pretty deep level of how they actually work, but from a high level perspective, how they work is that they use satellite and GPS techniques to actually know where each swarm robot is relative to each other. And they have a camera and sensors equipped onto them so that they can actually deploy a model and take photos of Magnolia phyta plants in the rainforest and classify them, identify their species, or find new species. So they work with each other in the rainforest and scan tons of area to find new species of Magnolia phyta for us in our database. Now, here's what's actually really important. So we're surveying Magnolia phyta in the rainforest. We're using swarm robots and machine learning, these really complicated things, but what's the actual impact and possible gains from doing this? Well, there's this really important case study that I'd like you guys to focus on for a second. Approximately 7,000 medical compounds prescribed by Western doctors are derived from plants. These drugs have an estimated retail value of $43 billion US dollars in 1985. 70% of the 3,000 plants identified by the US National Cancer Institute as having anti-cancer properties are endemic to the rainforest. Endemic meaning specifically native to the rainforest. What this means is that basically we have all these plant species, some Magnolia phyta, some other phyla, that are so crucial for healthcare and so much value from a US perspective and global perspective for humans. But they're so untapped because we haven't identified enough species in the rainforest and we were not protecting them enough. So we have these sources of immense economic value compared to mere cows of $800, but we're not prioritizing them enough, and we're not diving deep into the rainforest enough to actually focus and catalog them. This brings me to my second point about implementation. So community collaboration. Unfortunately, right now with our solutions to energy storage, electricity generation, and these other innovations in the rainforest like dams, the issue is they often relocate or damage indigenous community species. And this is really bad from a moral perspective of not wanting to hurt humans, but also these indigenous communities have tons of insights and knowledge beyond what we know about the Amazon and its value. And so it doesn't make actual sense to harm indigenous people instead of working with them. So we propose actually collaborating with these indigenous communities with our solutions and making sure that we're not harming them, but instead working with them to find more insights and to catalog more species and to access more knowledge about the rainforest. So here's our next steps. For our data set for our CNN, we need to train our model to be able to identify species and find new species with really high accuracy. But there's so many species in Magnolia phyta. There's over 220,000 with potentially way more, right? So you need to find a way to actually get this huge data set to actually train our CNN. And our approach for this now is crowdsourcing. So reaching out to researchers, experts, and people in the field and incentivizing them with the potential of new insights and new products to actually get data for a CNN. Our main focus is that because the CNN is a core part of our solution to actually finding new species and cataloging species. So overall, we propose leveraging CNNs and swarm robots to catalog biodiversity, specifically Magnolia phyta species. This is because the potential economic gains from our insights in these species could be worth way more than just cows. Cows worth 800 USD, whereas the retail value of herbal medicine, which largely comes from the rainforest, is $45 billion. There's so much more potential for money with herbal medicines, Magnolia phyta, and other plant species, but it's so untapped and it's so unfocused on. So our plan is to actually leverage Magnolia phyta and other species and find ways to not only pay Brazilian workers and fix their economy, but also progress humanity and find new sources of healthcare and products from these species. Overall, we think it's important to help Brazil and help the Amazon with growing back and fighting deforestation, but it's also important to help humanity find new sources to our problems through species cataloging and identification. Thanks for watching.